Hello listeners, and welcome to the fourth program in our series of Let's Learn Life Science, which is actually produced for grade 8 learners and anybody else who has an interest in a subject. My name is Mr. Hanganini Levinegwila. Today, we will learn about some aspects of estimating and measuring scientific processes. As usual, please have a pen and a notebook ready so that you can make notes of important points. And after listening to this program, you should be able to follow a sequence of diagrammatic and written instructions and record estimates and measurements. Use appropriate techniques, handle apparatus or material competently and with due regard to safety, and calculate magnification of an object or specimen. It is actually very important for you to understand and follow instruction in scientific processes. So, let's do a quick activity before we proceed.
Sir!
Yes, Jack?
I can attest to that. My friends never followed instructions in a home economics cooking class. Every time we saw and tested her food, it looked weird and did not taste nice at all. I later found out she simply mixed all ingredients together and never followed the recipes.
Thank you very much, Jack, for that relatable example. We can all relate to food or preparing food. I'm sure your example and today's discussion will inspire us to follow instructions to the dot, even in recipes.
I never looked at it that way. I've just learned to appreciate instructions.
Now, let's look at an example of the instructions below. They are not in the correct order. We have 2 beakers and we want to find out how long it will take for the ice cubes to melt. Let us listen to the following instructions and try to arrange them in the correct order. The instructions are as follows. Number 1, put the ice cubes in the 2 beakers. Number 2, time how long it will take for the ice to melt. Number 3, put 2 identical beakers on the desk. Number 4, break one of the ice cubes into smaller pieces.
I think the correct order is number 1, put 2 identical beakers on the desk. Number 2, break one of the ice cubes into smaller pieces. Number 3, put the ice cubes into 2 beakers. And last but not least, number 4, time how long it takes for the ice to melt.
Is Jack correct?
Yes, sir, he is. We start with the beakers, then we break the ice. Thereafter, we place the ice in the prepared beakers, and finally, we time how long it takes for the ice to melt.
Well done, guys. You are both correct. It is very important to always follow instructions. The same applies to safety rules and procedures because there are many possible dangers that can come as a result of not following instructions to do activities or experiments safely.
I totally understand the importance of following instructions, especially when one is dealing with dangerous materials or equipment.
In any laboratory, it is very important to adhere to safety rules and procedures. During your science lessons, you will work with equipment and materials that can harm you. For this reason, you must always behave in an orderly and responsible manner when you are in the laboratory. But remember, following instructions and safety rules and procedures are also important in our daily lives. The following basic safety rules will help to keep you safe in the laboratory. Jack, please read the first 3 and Ander will follow after you with the next 3. And then I will read the rest.
Yes, Mr. Bum. They read as follows. Number 1, do not enter the laboratory unless you are accompanied by a teacher. Number 2, do not run around or play in the laboratory. Number 3, handle all equipment carefully. Some pieces of equipment are fragile and can easily break.
You are right. But sometimes learners are so naughty or just curious, but they can harm themselves if they enter a laboratory without supervision or permission. Learners should always obey to this rule. When learners are naughty or curious, they want to play around and experiment with equipment and materials. But if these equipment or materials are not handled correctly, it can lead to serious accidents in the laboratory. Endo, will you read the next 3?
Yes, Mr. Baum. 4. Never perform experiments that have not been approved by your teacher. 5. Do not touch or tamper with any gas taps, sockets, or wiring in the laboratory. And 6. Never eat or drink while in the laboratory. Food or drink can be contaminated by bacteria.
Thank you very much, Endo. Learning about science through experiment and activities is good practice, but it requires discipline and order. The last 3 rules are: number 7, if there is an accident involve fire, cuts, broken apparatus, chemical aspirages, or gas smells in the laboratory, report it to the teacher immediately. Number 8, wash your hands after each practical activity. Number 9, know the location and use all safety equipment such as fire extinguishers, fire blankets, first aid kit or box, eye wash, goggles, and aprons, just to mention a few. Now that you looked at the safety rules and procedures, let's focus our attention on calculating the magnification of an object or specimen.
Yes, sir. I wanted to give an example.
Go ahead, please.
An ant is very small in size, but I can take a picture of it and enlarge it on my phone using the zoom function.
Yes, that's a good example. Check?
Yes, sir. My mom once ordered a bag from the catalog, but she didn't check the size and all the measurements. A week later, she received it and she was unhappy because the bag was very small. I think the picture she saw was not a good one, or maybe it was an enlarged version of the bag.
You are indeed correct, both of you guys. Pictures actually never gave us or show us the exact size of an object. That's why when it comes to scientific drawings of specimens or objects, it is necessary to find out how many times a drawing was enlarged or reduced compared to its original size.
That's the mistake my mom made. Maybe she didn't know about the 2 lengths, the one of the real object as opposed to the given picture. Maybe my mom also did not read carefully because the measurements of the bag were actually given in the catalog.
You may be correct, but in science, you will be required to make drawings of specimens or objects you observe. Our drawing size will often be different from the real specimen or object. Let's use Endo's example of an ant. When you draw an ant, the size of your drawing will be different from the real or actual size of the ant. Not to worry though, because you can calculate magnification of your drawing. We use the formula magnification is equal to the size of drawing divided by the size of actual object. The length of an ant is given as 8 millimeters. In order for you to find the magnification, you need to measure the length of your drawing in the same units, which is millimeters. Let's say, for example, that when you measure the length of the drawing, you got 80 millimeters.
Sir, I would like to try it.
Go ahead, please.
I'll use the formula. Magnification equals the size of the drawing divided by the size of the actual object. Then I will substitute the words in the formula with the actual numbers. For example, magnification equals 80 millimeters divided by 8 millimeters. I will get the answers of the magnification equal 10 times. That means the drawing is 10 times the size of the actual size of the object.
The drawing has been enlarged, which means it is bigger than the actual length. Therefore, we put the numbers above the division line in the formula, while the actual length of an ant comes below the division line in the formula. There are 2 important things to always remember when it comes to magnification. First, always round off your answer to 1 decimal place, and second, always write the magnification next to the drawing.
Awesome, sir. Calculating magnification of objects or specimens is actually easy now that I understand how to do it.
Fantastic, Jack. It is really exciting to hear that. So, Ando, can you please emphasize on what we have learned today?
Yes, Mr. Baum. Today we looked at the importance of following instructions, safety rules and procedures in a laboratory. Working with equipment and materials could harm you if you're not careful. For this reason, you must always behave in an orderly and responsible manner when you are in the laboratory. 1. Do not enter the laboratory unless you are accompanied by a teacher. 2. Do not run around or play in the laboratory. 3. Handle all equipment carefully. Some pieces of equipment are fragile and can easily break. 4. Never perform experiments that have not been approved by your teacher. 5. Do not touch or tamper with any gas taps, sockets, or wiring in the laboratory. 6. Never eat or drink while in the laboratory. Food or drink can be contaminated by bacteria. 7. If there's an accident involving fire, cuts, broken apparatus, chemical spillages, or gas smells in the laboratory, report it to the teacher immediately. 8. Wash your hands after each practical activity. 9. Know the location and use of all safety equipment such as fire extinguishers, fire blankets, first aid kit or box, eye wash, goggles, apron, and so on. We use the formula magnification is equal to the size of a drawing divided by the size of an actual object to calculate magnification. In order to find the magnification, you need to measure the length of your drawing in the same units as that of the object given. In the example of the ant, we discussed that the drawing has been enlarged, so it is bigger than the actual length. Therefore, we put the drawing length above the division line in the formula, while the object's length came below the division line in the formula. Always remember to round off your answer to 1 decimal place and always write the magnification next to the drawing.
Job well done, Endo. Here is an activity for you. Number 1. List any 5 of the safety rules and procedures in the laboratory. Number 2. Pick a leaf, dry or fresh. Measure the length of the leaf and record it. Make a bigger drawing on your notebook. Measure the length of your drawing and calculate its magnification. With that, we have come to the end. This program was written by Shiva Kambata. So until next time, take care.
This program was brought to you by NAMCOL with funding from the Ministry of Education, Arts and Culture and the Commonwealth of Learning.